Welcome to this introduction video about the Asyst version 2 pipe calculation tool. Over the next few minutes, we'll show you how to use the tool. If you are using the tool for the first time, you need to make sure that your preferences have been set correctly. To do this, go to Options, then Preferences, and check the unit system and the hole size precision. If you select Medium, the tool will only suggest hole diameters in increments of 0.5 millimeters. If you select Fine, it will apply increments of 0.1 millimeter. You can also define the default inner diameter for pipes, which is usually 21 millimeters, as well as the default inner diameter for capillary tubes, which is typically 4 millimeters. From this point on, whenever you create a new configuration, the tool will load the parameters based on the preferences you have selected. There are essentially two options for calculating a project using the Asyst tool. You can either use a template and adapt it, or create a configuration from scratch. If you are just starting out, the easiest option is to use a template. This is a straightforward process and enables you to set up a pipe topology with just a few clicks. To use this option, go to the folder icon called Open Configuration and select the template folder plus the relevant ASD device. The templates are named according to the pipe networks associated with them. In our case, the U-pipe is the most appropriate choice for the project. Don't forget that a pipe layout is essential for implementing a project correctly. The tool will now load the template. Our first step is to define the site configuration properties by selecting the first icon in the tree view. We will keep the configuration name and change the customer name to Siemens. Once the configuration properties are set, our next step is to set the detector-specific properties by selecting the detector icon. It is essential to define the required fire standard, the environment, and the ambient conditions that apply to the area in which the ASD is being installed. Based on what has been entered, the tool suggests the most suitable parameter set and detection mode. If an ASD is being installed in a dust-free area, for example, then the clean room environment needs to be selected. The altitude and temperature have an impact on the air density and will therefore affect the transportation time. If a high ambient airflow is present, then the crosswind needs to be set. This setting will result in higher pressure at the holes. The relative pressure value is required if the ASD is being installed outside of the protected area where the pipe network is being installed. There is usually a certain difference in the pressure levels. Once the site configuration and device properties are set, we can then expand the entire tree to see the pipe segments. To see more details about a specific pipe segment, switch to the Table Editor. As you can see, the template shows 4 holes and a total pipe length of 17 meters. Based on our project information, we need to adapt pipe segment 1.1 by adding one more hole. Simply select a hole, right-click on it, and then enter a hole before or after it. The next step is to adapt the pipe length and the positions of the holes. As you can see, we have two options for entering the values. We can use the absolute distance from either the device or the predecessor. For the total pipe length, we need to enter the value in the row containing the distance from the device. In this case, we need to change the value from 17 to 25 meters. The second last hole is at a position of 21 meters. And so on, according to the job site specification. The row on the left indicates the distance from the predecessor. Now that we have completed the first pipe segment, we can do the same for a second pipe segment. The most efficient way of doing this is to copy pipe segment 1.1 and paste it onto the T branch. In order to do this, we need to delete the second pipe segment first. At this point, we are now ready to calculate the pipe network. Let's summarize briefly. So far, we have incorporated the pipe network as well as the device and the site properties. For standard applications, you can keep the default settings that the tool suggests. However, you can change the settings if you want to optimize ASD operation. For instance, changing the hole diameter from a proposed to a fixed value will change all the holes in the pipe network to the same diameter. This creates an advantage for the installer, as it means that he or she can drill the same size of hole throughout the entire pipe network. You can use the speed specification to optimize the noise level and power consumption. Last but not least, you can use the parameter set to manually calculate and check if the sensitivity level of the holes meets the required fire standard. The Apply button will check the consistency of the values that have been entered. If the calculation button is grayed out after you click Apply, this means that you are outside the detector limit. In our case, however, we are able to use the Calculate button, meaning that we are within the detector range. Once the calculation is complete, the result from the system will indicate whether the pipe network meets the required fire standard. The configuration results are shown in the bottom left-hand corner. The first three parameters need to be configured in the ASD. The tool also shows additional system results. On the right-hand side of the table view window, you can see the calculated diameter, the sensitivity, and additional information for each hole. If you want to understand your calculated design in more detail, you can switch to the sector results. There, you can see detailed information about the pipe segments, such as hole share and hole balance. The greater the balance percentage is, the closer this makes the sensitivity between the sampling holes. You've now seen how easy it is to set up a project using a template. Let's take a look at the second option, starting from scratch. First of all, we're going to create a new configuration. When you click on the icon, the tool adds a new configuration. Once the configuration properties are set, our next step is to set the detector-specific properties by selecting the detector icon. It is essential to define the required fire standard, the environment, and the ambient conditions that apply to the area in which the ASD is being installed. The next step is to start building the pipe network. To add a pipe segment, you select the detector, right-click on it, and select New, followed by Pipe Segment. In the Table Editor, we are able to change default value to 3 meters, for example. We can then carry on building up the pipe network. To do this, go back to the tree view. Right-click on Pipe Segment and add a T branch. In the graphic, you can see that there are 2 separate pipe segments once the sketch is centered. In order to complete the pipe network, we will add an end cap to both segments. Now we are ready to add elements such as holes and bends to a pipe segment. To add a bend, select the cap end and right-click on it. We will now add 1 hole after the bend. To speed things up, we can also use the Copy command, Ctrl-C, to copy the selected element, and the Paste command, Ctrl-V, to add another 2 holes as well as 1 hole to the end cap. Once all of the elements have been added to the pipe segment, we need to change the total length of the pipe segment and adapt the hole position. To do this, change the total length in the row called Distance from Device to 22 meters. As you can see, the tool is now indicating that the highlighted value is outside the limit. However, since we are still in the process of adjusting the values, we can continue. The second last hole is at a position of 17 meters, and so on according to the job site specification. By the way, the status bar at the bottom line shows the current status. As you can see, we have already used 27 meters out of a total of 120 meters available, and 4 holes out of 32. The status bar also shows the fire standard class we are aiming for. In order to make the design more realistic, the tool features an excellent 3D graphical representation. You can rotate the whole topology by left-clicking on it and zoom in and out using the scroll wheel. By holding down the scroll wheel, you can also shift the whole topology left, right, up, or down in order to get a good overview of the entire pipe network. Let us now continue with the next step in our project, which involves changing the direction of the bend. To do this, select the bend and use the keyboard command Ctrl-R to rotate the bend by 90 degrees. Look at how this works in the graphic. To complete the project, simply delete pipe segment 1.2, then copy pipe segment 1.1 and paste it onto the T-branch. We're now ready to calculate. Take a look at the results. The top menu bar also contains an icon that you can use to set a default view for the graphic. This is very useful if, for example, you zoom in and manage to get lost somewhere. If you select this icon, the tool will automatically jump back to the front view, the side view, or the bottom view, depending on what you have selected. You can also use an icon to activate labels. This allows you to see which pipe segment has which number. If you select a pipe segment in the tree view, you will see the corresponding segment in the graphic highlighted in yellow. This makes it easy to find your way around. Let's take a look at the last feature in this introduction video, reporting. The report provides the installer with information about configuring the ASD. To use this feature, select the Create Report icon, and a report in PDF format will be created instantly. The first page of the report shows all the relevant parameters that need to be configured for the device. On the second page, the installer can find the information he or she needs for installing the pipe network. It is also possible to see the position and diameter of each hole, as well as the total pipe length. We hope you have found this information useful and that you're now ready to start your first project. If you have any other questions, please consult the manual or get in touch with your local support representative. Thanks a lot for watching, and goodbye.